Welcome, everybody. Thank you for joining us. My name is Tabitha Graves. I'm the Community Enablement Manager with AWS GameTech. And I have here with me the amazing Chris Finch.
Yeah, I don't know about that, but I am absolutely a solutions architect and evangelist for GameTech at AWS. I really appreciate everyone who's in the audience giving us your time today. We are here to talk about what LiveOps is and how you can use it to engage your players, keep them around, and help them to enjoy the game that you've made for them. So, with no further ado, Tabitha, take it away.
Yes, thank you, Chris. We're going to talk about what LiveOps is all about, and also how the game centers around the player journey. We can understand how LiveOps can significantly impact the player experience in the game that you are creating. So let's get started.
Look at the world that we live. Look how the evil is grown. All the innocence lost. We need a new beginning, man. The vision is off. We need to wage war. Yeah, we need to rage on. I'm here. War boots, I'ma buy a pair. No suits, just spice here. Grassroots is the right gear. I'm still fly like a pilot chair. Brave hearts never die in fear. I ain't a stranger to the danger. I'ma live and I'm dying here. Yeah. So I'm looking up more. Cause I know what I'm up for. Cause we need a change. And I'm starting an uproar. And nobody can stop us. Yeah, we starting to rock this. Yeah, starting to rock this.
Cool. So we're just going to talk about Fortnite, right?
We're not going to talk all about Fortnite, but last year the Fortnite Black Hole event was the largest LiveOps events in games. Over 7 million people watched across all platforms. And on Twitch alone, 1.7 million people were concurrent viewers. So right now, to stay relevant, LiveOps is absolutely critical. Not just players, but live streamers need new content too to fuel their ecosystem.
That's absolutely true. And while it is absolutely important to acknowledge that the success of Fortnite, when you talk about LiveOps, because they've made it big and they've made no bones about the fact that they've done it via LiveOps, it is just as important to acknowledge you don't need to be as big as Epic or have a game that has as many players as Fortnite to get results from incorporating LiveOps into your game. Butterscotch Shenanigans, for example, they, like all of us, understand the games industry is crowded and competitive, and one of the things they do to gain a competitive advantage in that marketplace is use LiveOps. What do? They actually use back-end automation via website APIs and serverless compute using AWS Lambda. It helps them to locate and build daily challenges for their players. Now, this is content that they actually synthesize from both official content and from user-generated content. And that's really cool because it's new content for their players, but it also happens regularly on a schedule. So that way their players not only know that Butterscotch Shenanigans is building them new stuff, but they know when to look for it. So players keep coming back. Butterscotch Shenanigans does this on a daily basis. So that's how they keep their engagement high. Their players come back on a daily basis. They know something's going to be new for them to play with, and they play with it.
And like everything at Amazon, we're going to start with the customer flywheel. So this is our LiveOps flywheel, where you can see that the player engagement is basically at the center of everything. And those examples that we just talked about with Butterscotch Shenanigans and with Epic Games with Fortnite, all of those were culminations of experiences rooted by the player engagement for those games. And all of those experiences were created specifically to increase that user experience. So at the highest level, a game is fueled by a cycle of design and development decisions. So when a game is launched, whether it be alpha, beta, or full-on production, players then engage with that content and start collecting, and then you start collecting player and game data. You then take that and analyze it, make adjustments, and pivot to the information, and that continues for the whole cycle for your game. Now, player engagement is at the center of everything. So LiveOps is the bridge that connects the developers to the players to let them know that you are listening.
Yeah, and so as a developer, it's really important to understand there's a takeaway here, right? And that's that if you're not collecting data, you can't build it into your next iteration of your design. So what's really important here is that you need to be building LiveOps into your game from day one. Okay, you can't incorporate that feedback if you don't have it. And the best way to understand how people are engaging with your game is not to ask them in a survey, but to actually analyze the data they generate as they're playing the game. People may not even understand how they're engaging with the game, but the data doesn't lie. The data will always tell you what's going on, and if you have it, then you know how to iterate on it.
Yeah, exactly. We want to be mindful of the player experience and being able to pivot at a moment's notice. Yep. So currently there is no community consensus of what defines LiveOps. So today we're going to talk about 3 pillars, which we believe most consistently called out by the game dev community. So let's go ahead and let's dive into community building. So community building is all about fostering that community through, social dashboards, specific team objectives. It's really about fueling that dynamic between the relationships between, the new elements that you're designing for your game, and then also within your game for community or sentiment management. So it's all about your players belonging to communities, having fun playing with friends, whether that's real time or not. It also brings about different mechanics for your game. So for live events, that is going back to the Fortnite Black Hole event, or, we've seen in the past the Marshmallow concerts, the Rocket that happened in Fortnite. All of those were created in order to foster that type of community building. And in order to build something like that in the cloud and to build that connected game, you would need services in order to handle all of those people coming onto all of those servers. So there are a couple ways of doing it. You can either on premises, you can have a whole bunch of servers where you host different events like that. With AWS, we have Amazon EC2, which also has auto scaling. Now, what this does is with EC2, it doesn't allow you to over provision. So back in the day, if you are building something like on premises, you want to have more servers in order to have that right experience for the gamers playing on your game. Now, EC2 allows you to not over provision, allows you to just use the resources that you're using. And with auto scaling, it'll actually scale up and give you servers depending on how many people are joining. And then it'll scale back down so you only pay for actually what you use. So it's able to handle those amount of requests and make sure that you have the capacity and the demand to meet all of your players.
You're probably wondering why economy monitoring is in here under community building. The fact of the matter is that your game economy, for a lot of different game types, and especially any kind of game that allows in-game trade or auctions or anything like that, one of the most important things about your game community is its economy. A lot of players love this kind of interaction. They consider it as part of the game, playing the auction house, figuring out how to make money by making trades, that sort of thing, right? So there are a big subset of your community that really loves that kind of interaction. And other players over time start to learn to rely on the players who play that game to provide things provide like rare goods or bulk goods on an auction house or on a trade basis. So in this way, it's another aspect of your community that's being built up by some of your game mechanics, by some of your design, your economic design. So understanding how your drops and how the items in your game affect that economy is really critical to maintaining a healthy in-game community, as well as managing your financial expectations from in-app purchases, especially when those drops can be both farmed and bought from like an in-game store, right? Now, the problem here is that understanding, especially a complex economy web, can be super, super tough. When you've got to farm Boss X to get Phoenix Beaks as drops, and then you buy Miracle Water from the in-game stores. You can create a sort of hacking, so you can farm Boss A to now get Owlbear Claws. You know, the whole process of doing that, all those relationships can start to get hard to track as they start to cascade across tiers. And then as you release new content, it gets even tougher. Not just because you have more items to track, but because you want players to get through the old content a little quicker so they can actually experience the new content with their friends. So you tweak settings and you make things a little bit easier and things drop a bit more often. And this is where the landmines happen, because if you tweak things too much, you can actually mess up your in-game economy, you can mess up your IAP, and you can actually mess with the players who enjoy doing these things as jobs. So one creative way of solving this problem we've seen has been to let the designer model the economy in a graph database. Now, for anyone who isn't familiar with the graph database, think of it as like a big 3D model, right? You know, you got vertices, little points, and then you've got edges between them, right? And then the whole thing kind of comes together in a big net. So the vertices are the individual item types. Yes, they're actually the data, right? And then the edges are the relationships between those data. So you'd see, like you could say, show me all the connections to the sort of hacking. And you'd see Boss X, you'd see the Beaksy drops, you'd see the water you buy, you'd see Boss A that you can farm after you're done with him. You'd see this whole interconnection, this web of how these things interrelate. And what's really useful about that is that as part of those data, you can actually tweak the drop percents, and you can see how changing those percents across the entire web will affect things downstream and upstream as well. So it lets you tweak the numbers and see results across the entire economy. So that's just one really creative way of helping to understand not just the live event piece of your community, but your economy monitoring, your financial folks who really enjoy playing those kinds of games. As always, for something like this, you can build your own on a server or an EC2 instance. There's plenty of there's a couple of really well-known open source tools to let you do that. Or you can look to Amazon Neptune as a way to let AWS manage the infrastructure. Amazon Neptune is a managed graph database that you can summon up using your AWS dashboard. And either way, you can let this graph database manage the game data for you.
And for social campaigns, so as you are creating, and so as you are going through, creating the economy monitoring service or live events, you're going through and doing that, you want to be able to track to see what everyone else thinks about it. So whether or not you've had a recent launch or a recent update for your game or something patched, you're able to go through and create a social campaign or like a dashboard to where you can view sentiment management. So you can go through forums or maybe on Discord or Twitter and pick up on keywords and see what the community is thinking about the recent releases. So something like this, where actually you can use natural language processing tools. Now, those are, open source services and things that you can do. With AWS, we have Amazon Comprehend, which is another managed service. It is pay as you go, but you don't have to have your own infrastructure or have your own servers. It's still a natural language processing service, and it uses machine learning to find insights and relationships in that text. So you can go back to the campaigns and actually see what worked, what didn't work, and what the community is thinking about your game, either through actual keywords or just a general sentiment of the community.
Yep, good stuff. So what we're going to do right now is we're going to take you through a really quick example of one of the ways that you can use Comprehend to help understand what's going on in your community. What we're looking right here, this is a community sentiment management dashboard. There's actually a CloudFormation template and a way to spin this up in your own account right now. You can find a link for this after you're done with the session. The whole point of this thing, if you look at this as a whole right now, is that it's a way for you to visualize how people are talking about your game, right? And now the way it does it, we'll walk through this really quickly. We're taking data in this case from Twitter. It doesn't have to be Twitter. This can be, you could have a bot sitting in your Discord app. You could be pulling Reddit threads. You can pull this data that is pertinent to your game from any social media source that you like. Almost everybody has APIs where you can do this now. But we can use Twitter as the example because it's easy mode, and it's actually the one that you can spin up immediately on the sample. So what you do is you pull all of the Twitter tweets down from that are pertinent to your game. You can do it by keyword, you can do it by hashtag, however. And what you're doing is that you're running them all through a service called Amazon Kinesis Firehose. And what that is basically, you need a service that's going to be able to take lots of volume, right? You're going to be pulling all sorts of social media down all at the same time. And what Kinesis Firehose does, it gives you basically an endpoint that you can jam lots of data through. So you're spinning all this data from Twitter through Kinesis Firehose. And what Kinesis then does is it takes that raw data and it spits it into an S3 bucket, right? Now, an S3 bucket is just object storage. So all it's doing is it's taking the raw records that Twitter has sent you via Kinesis Firehose, and it's letting them sit in this raw bucket OData, right? So what ends up happening is either on an interval basis or on a trigger basis, when you get more data, when more data drops into that S3 bucket, Lambda fires up. What's Lambda? Lambda is what we call serverless compute. It's basically a way to have a program running without having to provision a server. That's why it's serverless. So what it's going to do is it's going to go into that raw bucket and say, hey, we got more data. Let's go process this stuff and see what people think about it. So it grabs that data from that raw bucket and it jets it over to first Translate to make sure, AWS, Amazon Translate, to make sure it's all in the same base language. You want to be comparing apples to apples when you look at sentiment. And when you're evaluating the data later, when you're trying to look at it and spin through it and visualize it on your own. So you send it to Translate to get it all into a single core base language. And then what you do is you send the results into Comprehend. And Comprehend does exactly what Tabitha was just saying. It's going to go through, it's going to identify keywords, what people are talking about most, and it's going to give you sentiment analysis on those tweets as well. So, okay, this is a positive, this is a negative. Yeah, they really like this thing here, and we're kind of getting a lot of negative stuff about this stuff down here. So you're grabbing all that cool data. You're grabbing all that cool enriched data now, because now you've got sentiment analysis and keywords associated with it. And you're once again sending it into Kinesis Firehose. Again, this is supporting a really super high expectation of tweets of social media. We got a lot of stuff coming through. We're going to then take it, send it through Kinesis Firehose, and Kinesis Firehose will take the now enriched data and dump that into a different bucket. Of course, you want two different buckets because you don't want to mix up their old raw data with the new cool metadata enriched stuff, right? So now you've got that. Now what you can do is you can start to look at that data with something like Athena. And what Athena does, it basically lets you run queries in place. So if you're familiar with SQL, you can say, hey, show me all the positive sentiments for today, or all the highest, all the biggest keywords per day for the last week, that kind of a thing, right? Glue works with Athena. What Glue basically does is it crawls the data that's in that enriched bucket and figures out what the format is, so you don't have to. So if it's coming in comma separated, or whatever format you've decided to stick it into, I think Parquet is the one that Athena and Glue like best. But it'll take the data you've dumped in there and it will figure out what the best format is for it to then run queries off of. And once you've done that, then you can use a tool like Amazon QuickSight, which actually lets you visualize these things. So you can see graphs over time. So, okay, this got more positive, or this got more negative, or this has stayed pretty much the same over the amount of time. So what this does is it gives your social team the ability to have pretty darn immediate mode information at their fingertips as to what the community thinks about it. This is really useful for like when you release DLCs, or if you just released your game, or if you have a patch that just went out that changed some gameplay. You can monitor this stuff in nearly real time, and your team can say, hey, people like this, we need to change this, we need to revert, this is not going well. So that's the dashboard, that's what we're looking at, and that's one way that you can use technology, specifically AWS in this case, to help you with your LiveOps experience and your players' experience.
Now, Chris, correct me if I'm wrong, but this is currently set up for Twitter. You can do this sort of dashboard for other services, correct?
Yep, absolutely. Yeah, this is you could set up, like I said, a Discord bot, which would then take the place of the Twitter feed, and the bot could talk directly to Kinesis Firehose. There's a bunch of different ways to do this. You can even hook this up to your in-game chat. And have your in-game chat spin out directly to Kinesis Firehose and then dump that data. So you can decide to segregate that data, you can merge that data, you can get kind of a whole holistic view of how people are perceiving your game that way. Cool. So since we've kind of gotten into this anyway, we're just going to go straight into the whole second pillar of measuring and responding to player behavior. So first, what we've done is we've driven a community around your game. So now we have people who are enjoying your game, playing it together, which is awesome. Now what we want to do is we want to understand how they're playing your game, what they're doing specifically, what they're spending the most time doing, how much they enjoy it, that kind of stuff, right? So as we're measuring and responding to that player behavior, one of the things we should be doing is helping people to understand the kinds of content that they enjoy and pointing them at that content where it exists in our game. Okay. So that's what activity analysis does. And one of the easiest ways to do it is as you're gathering data on those players, compare the results of players to each other and find out where, so if player A and player me are very similar players, we do similar other kinds of things. We both like PvP. We both like this particular zone over there. And yet player A has done thing X, or has gone through this quest line, and I haven't. Then the recommendation engine can start to say, hey, you're kind of like this guy over here, and this guy over here a little like this thing. You might too. That's the basics behind a recommendation. Now, it's important to acknowledge that you normally think of a recommendation engine as something that you use with an in-game store, and you can certainly use it that way, right? Person X who plays like you do, they bought item Q, so maybe you should too. That's the obvious way to use a recommendation engine, and you can certainly do that. But don't get pulled into the trap of thinking that you're stuck with IAP recommendations when your recommendation engine can do so many more things. Think of a recommendation engine as something, a tool, that can suggest anything to a player that they or their character can possess or consume, right? So, IAP is the obvious thing, but I was just talking about quests. If this player A over here has done this cool quest and I haven't, then chances are, hey, you know what? You might like this quest. So you can, a little advisor angel at your shoulder, or a little kind of a UI that suggests what to do next. You can build these kinds of things into your game, so that way it's not necessarily driving an explicit IAP play, but you're helping engage your players because you're helping them to find more quickly the things that they like to do, right? You could use it to point players towards items that enhance their performance. Like if they're a PvP player and at the end of this quest line over here, you can get, or this activity over here, you get a cool sword that actually helps their class. Then you can say, hey, if you go do this activity until this point over here, a lot of players like you have found that they got a real benefit from doing that. So, the important thing to remember about a recommendation engine is it's not really just about getting people to buy things. It's about helping your players locate the things they like to do in your game more quickly, which increases your engagement. So as always, you can do this one of two ways. You can run your own recommendation engine on your own hardware. You can do that on an EC2 virtual instance or on any kind of virtual instance, or you can use Amazon Personalize. And what's neat about Personalize is it is a managed service. So once again, you don't have to provision your own hardware. You don't have to worry about configuring or updating or maintaining your own servers, nothing like that. You just set it up. It will provide you with a simple API to query against, so it's actually also very easy to code too. So that's one way to get started in this world of recommendation engines, to help your players find things they like to do.
Thanks, Chris. And so as you are looking at the different type of player behavior, you also want to look at, what does not normal look like? So not just measuring, what people are doing and making recommendations based on that, but are you able to detect any sort of anomalies and respond to different threats that actually might impact your game? Some of these might be, like fraud detection, with player management, you can do that, any sort of player context. You're able to actually identify either something specific that you're looking for, like bad behavior, or maybe understanding a general blanket trend that's happening right now, of identifying maybe suspicious activity that's happening and you may not know exactly why it's happening. So you can do this in a couple different ways. So you can do it through AIML, which is artificial intelligence, machine learning. So you can actually design and have these strategic frameworks set up to where you can either go looking for, a specific, like I said, or something, more blanket statement of understanding a general trend, looking specifically for those anomalies. Now, You can use the regular frameworks that are set up, or with AWS, there's a service called Amazon SageMaker, which is fully managed. And you're able to build and train and deploy those actual machine learning models very quickly. So you can actually go through and set it up, and then just kind of let it sit and then determine and analyze that content at the end. We actually have a video, or we actually have another session, Nick Walsh is leading that, on leveraging AWS machine learning and artificial intelligence and building a dynamic and performant end-to-end abuse detection pipeline. So make sure after this session to check that out.
Yeah, and what we'll do as well is, if you don't have the time to, we'll walk through his architecture very briefly here at the end of this this column. Remember, for machine learning, this can be a really difficult topic for a lot of folks to get into. Understand that what machine learning is at its core, it's just about detecting patterns and anomalies. So that's really where its strongest use cases lie. As Tabitha intimated earlier, when you detect those anomalies, you detect groupings. It's the best way to handle threat detections. That's really what we're talking about when we're talking about that. And again, we'll get into that in a second.
Absolutely.
We've been talking about measuring and responding to all of these data. One of the things we haven't really spoken entirely about has been how to collect it in the first place, and then how often we can deal with it once we collected it. So the topic here is about live procedural engagements. Now, what does that mean? If you have a game that has static content and you've built static content for your players, over time, of course, what's going to happen is your players are going to get bored of it. So one of the ways to increase engagement is to leave surprises out there in the world that they thought they knew, and to do it in such a way that it's not necessarily consistent, but it's consistent it's not necessarily consistent. They won't always go to the same place and have the same encounter, but your server can understand what the rules of engagement are, and be able to generate these procedural engagements based on live analytics that are coming out of your game. So how to do that? Well, real-time data streaming is what we're talking about here. So it's kind of the thing we were talking about at the beginning with the flywheel. If you haven't built in the ability to grab player analytics from the beginning, then you're losing out. And this is one of the ways you lose out, because this is how you get the data out of the game. You're streaming the data out. And we talked about Firehose in a previous slide, pulling data out of Twitter. This is also pulling data. We're talking about pulling data out of your game. So your server is actually feeding the data of all the players that are playing your game at the same time into a very similar kind of a pipeline. And what you're able to do is you're able to take that data and dump it and enrich it, very much like in the way we discussed for that Twitter feed we were talking about. But we can also look at windows in time of that data as it passes through that pipeline. It's not necessarily just looking at, okay, I've dumped all this data, and a minute or 5 minutes or 10 minutes or a day later, I can then sort through it. You can certainly do that, and that approach has merit. But what this allows you to do is it allows you to do things like alerts in near real time. Say, hey, I detected a bunch of players over at these coordinates in this zone, sort of a thing. So back to the old static world where there's no surprises, if I can detect, a lone explorer out in the middle of nowhere suddenly doing something, I can pull from a database of procedural engagements and have him meet an NPC that no one's met before, or have an encounter with some monsters that are coming in the next expansion. Do some interesting things with your game to actually help people understand that, hey, you know what? This world there's more stuff going on here than these old quest lines and the stuff that we're familiar with. And again, the whole point of this is to increase engagement. If you have people out there searching your world for interesting stuff, then they're spending more time in your game, and they're having more fun doing it. You're providing them more stuff to do in that game. So it's not just a matter of them spending more time in it. They're engaging in it. They're having fun. They're finding stuff to play with. And that's the important thing. So the tool you'd use for that would be a real-time data streaming service. You're going to be pulling things out of the game, dropping them into this real-time data streaming service, and then operating on that data, whether in Windows or later on in batch. You do this just like with just about everything else. You can do this. You can provision a data streamer on your own server. Kafka is a very popular one. You do it on an EC2 if you like. You can also use Amazon Kinesis data streams or Amazon Kinesis Firehose, which is what we've talked about prior to now. Again, the nice thing about Kinesis compared to running your own is that it manages things like scaling and maintenance and updates and security for you, so you don't have to. I mean, obviously you've got to set up your security right to begin with, but after that, after that's taken care of, you don't have to worry about new hacks because updates and things like that. That's all stuff. That's security of the cloud, and that's what Amazon is responsible for. So that's how you can use Amazon Kinesis to get people more engaged in your game as they're playing it through live procedural engagements.
And Chris, you mentioned before with Nick's session, we're actually going to go through one of the slides and examples that he has.
Thanks. Yeah, exactly, Tabitha. Now, what we've talked about up till now is what we do with the data once we've gotten it. We haven't really talked about how we gather that data. So let's talk about that really briefly now, as well as how to play with that data, not only after we've gotten it, but as we're getting it. So the topic is live procedural engagements. And what that means is, so Kinesis Firehose we've talked about before. This was the way that we pulled data from Twitter to grab all the social media data that people are talking about. We can also do this for your game, right? You can be taking all the data that's coming out of your game and gather that data to understand how your players are interacting with it. You can get XY coordinates, you can get what kinds of actions they're doing, when they're doing them, who they're partied with, kind of anything that's happening in your game, you can report on, and you can put it into this Kinesis Firehose and then collect that data to analyze it at a later point. Now the key here is that you can analyze it at a later point, and again, you want to do that. That's kind of what we were talking about in the very beginning with the flywheel, when we're looking at taking player data and operating on it to help your designers understand what's working and what's not within the game design. So what this is allowing you to do is it's allowing you to do that, but it's also allowing you to operate on that data much sooner than that. So if you've got a way to respond to events that are happening in game that are interesting to you as a designer and that can help your players feel more engaged in the game, that this is your opportunity to do that. So what Kinesis does, in addition to allowing you to stream all that data into an S3 bucket and operate on it later, is it allows you to look at the data as it's coming through the pipeline in like windows of time, right? And you can actually do like SQL queries against those windows of time. So what you can do is you can get alerts, or the game can respond when it detects a single person out in the middle of nowhere for no good reason. There's no mobs out there, there's no quests out there. Why is he out there? We don't know, but he's doing something interesting. So we can be alerted on that. Or we can say, hey, there's a large group of ad hoc players around the specific area right now. Let's do something with them because it's, they're gathered and they're in this area, and what they're doing is they're not necessarily expecting anything to happen, because up until now your world's been static, and the content people go through is the content people go through. It's the content everybody goes through. So the world feels less alive, and the players think they know what to expect. What this allows you to do is make this world of yours feel alive again by surprising players. Okay, I've detected this one player out in the middle of nowhere. Let's throw a couple of monsters at him that are going to come in the next X pack and no one's seen before, and give him a story to tell, right? Or okay, this whole group of people has showed up over here. Let's do an invasion, or let's do a caravan where there's a trader with rare goods. Let's do something for these players that have gathered that is in our database of things that we can do, but that isn't normally part of what they expect to see where they're playing the game. And again, so what this does, it allows your previously static world to feel more alive, and it allows it to engage your players, because what they're going to be doing now is they're going to be spending more time in your game looking for stuff like that. So those live procedural engagements are generated by being able to look at what your players are doing right now in the game. It's almost like having your automated dungeon master. Okay, oh, my players are playing in this ruin over here. Let's give them an encounter. It's almost like that. So that's how you can use the real-time data streaming using Kinesis, using any real-time data streaming technology. Kafka works on your own servers if you want. Kafka works on EC2, or you can use Kinesis Firehose or Kinesis Data Streams, both of which are managed services. Firehose is fully managed, so that we can handle things like scaling for you. And for both of those, you don't have to worry about configuring your own server. You don't have to worry about updates. Amazon handles those things for you. So that's how you can use real-time data streaming to generate live procedural engagements and keep your players engaged.
Now, Chris, let's actually dive a little deeper into the model that we talked about earlier with Nick's session with the unsupervised learning pipeline.
Cool. Yeah, I won't go into this in quite as much depth as he will, but I do want to give you a basic overview, so we'll go through that right now. So step one in the bottom left-hand quadrant, if you see it says acquire data and create data lake. So what's a data lake? Basically, it's that green S3 bucket in the quadrant. That's where you're putting all the data you're collecting. We were doing the same thing with the Twitter example. We're collecting all the tweets and we're putting it into an object, then operating on that data, and then taking the data and slapping it into a new bucket. That bucket is now our data lake. It's where all of our data is sitting. That's for us to be able to work with and operate on later. It's all of our raw data. We never have to get rid of it. It's very cheap to use S3 to do this because you're just storing objects, but it allows us to operate it on it as structured data later on. So we'll talk about that. So the EC2 in the bottom left-hand quadrant, that's your game server. And what it's doing is it's using Kinesis Firehose, like we just talked about, to jet all of its player data into that Kinesis Firehose, which is then dumping it into this S3 bucket. Okay, and then what's happening is Glue, which is what we also talked about in that prior slide. Glue is operating on that data and it's finding the best formats. That way you can then query that data, or that way a service can understand the format of that data and then operate on it. And that's kind of what we're doing here, right? Again, to back up what Tabitha was saying, this is specifically about being able to detect player behavior that's funny, right? Okay, players are not necessarily acting. These are player threats, so we're trying to detect anomalous player behavior. SageMaker does a really good job of that. So once that data is in S3, Amazon Glue crawls that data, provides it with the format that it needs to be able to understand how to operate on it, and then dumps it in the new enriched data bucket, in the new enriched data lake. SageMaker then goes through that data and is able to say, hey, okay, based on the model I've built previously, it looks to me like this data, this player right here might be doing something funny. Now, because of the nature of this kind of a pipeline, you don't necessarily want to ban somebody right away. That might not be the best thing in the world. But what it can do is it can flag the player for your ops team to look at. They can go in and watch how he's playing the game. They can look at his other records. It starts to give your team, it's a way to scale the abilities of your teams. That way they're not having to always look at all the players all the time, or just look at a small sample of players and hope that they're indicative of your other player base. What we're looking at here as well is that this pipeline feeds into itself, so that way we're also looking at established player data. So what we've done is we've taken that data that we've run through with SageMaker, we've crawled it to make sure we get the right format in it, and then what we can do is we can add pieces of those data back to the player records, which are in Amazon DynamoDB. That's why we have DynamoDB and Lambda back in the data lake in step one, because we have both the real-time data and the historical player data of what the player's done before, all feeding into what's going on, so we can analyze it and look for anomalous behavior. Because the important thing here, again, is anomaly. If a player always does something anomalous, it's not really an anomaly. So we need the player data to be able to understand whether that player is actually doing something that we don't expect him to do or not. And that's what helps us. That's what guides us to understand where those threats are. Again, you'll get the bigger talk when you talk to Nick later on, if you catch his presentation, but that's the short version of what we're doing here when we're looking for anomalous behavior in an unsupervised learning pipeline.
All right, and diving into the new content and features, which is going to be our third pillar for LiveOps. So new content and features. So all of this are culminations of what came in the two pillars before. So with managing, player behavior and then building your communities, this is really the effect of all of that, and looking at looking at what actually has happened in that development cycle, in that LiveOps cycle. So for the first one, for promotions, so looking at different, if your game has seasonal events, or maybe if you have an esports component to your game, promotions allow you, as a leaderboard is updating, to be able to notify the players that, they are no longer number one. Or maybe if your game has different seasons or holidays, as things are happening, you're able to build like a back-end calendar for your players to change it up and have those different in-game events. So all of this, whether you're having an update or a patch and you just want to notify your players on a mass level, you're able to do so through promotions or a push notification service. We have AWS has Amazon Pinpoint. Now this service allows you to send out push notifications, but it also has analytics. So it has a fully customizable dashboard, so you're able to segment your players. So if your game has different classes like mage, warrior, druid, you're actually able to put those players into those different user groups and have a tailored audience for the messages that you're deploying. Let's say if you have an update to druid and you only want them to know, you can actually just take that user group and then you're able to just send that push notification to only the druid players would be able to see what you guys did.
Yep, exactly. And we'll actually go through an example of that at the end of the new content and features column.
Yeah.
But for now, let's look at fast development. Obviously, one of the things you want to do is you want to get your content out to your players quickly. And the best way to do that is to make sure that you have a continuous integration and continuous deployment pipeline prepared. Getting releases out fast is really, really critical to engagement. You've all seen the horror story threads on Steam and on other game forums where people are waiting forever for the latest update that's supposed to solve all of the problems. Everyone's seen it. It's every developer's nightmare. And of course, every developer wants to meet those asks, right? They want to make their players happy. So being unable to do that is really a nightmare scenario. That's why one of the things you want to be able to make sure you can do is get that CI/CD pipeline running. It's a lot like when we spoke about that flywheel again and building LiveOps into your game from day one. Building CI/CD mechanisms into your process from day one can absolutely save you headaches, keep your players engaged from the start, rather than making you wait as you stumble through retrofitting your process. Now, at its core, CI/CD is really about automating your build process. When you push the build button, you're not just creating the build because you can do that right now, right? If you're using Unity as your game engine, you can push build, and oh, there's your exe. Great, I've got my game. Now, what do I have to do to actually get it to my players? Well, if I have a small player base, it's actually pretty straightforward, right? I give them a download link on Discord and we're done. Now, that's great until your game explodes and becomes extremely popular, or when you want to launch it on Steam. You then suddenly have to have either a bunch of manual processes that you really have to have a lot of faith that you can track accurately every time you do it, which is not really a safe, that's not a safe bet. Or you can have automation that allows you to push that button and not just generate the game exe, but actually pushes it to all of its destinations. That way, when you're done pushing that button, your gamers can get your game in all the ways they're normally accustomed to get. They can get it via Discord if that's still how you want to do it, but they can also get it by the Steam update that just came out, or the push to the CloudFront destinations. They can download the new DLC with their game client. This stuff is super, super important. So automating that build process saves all sorts of grief and makes your players a heck of a lot happy. So build that stuff in from day one. It can be as simple as having a tool like Jenkins, which runs the build process and just deposits your artifacts in the right targets. But if you build it from day one, you're going to be in a lot better place. You can also consider using AWS Code Pipeline, which is a fully managed continuous deployment service. Helps you automate the release pipelines. It automates build, it automates test, and it automates deployment every time there's a code change, which lets you deliver your working updates to your players super, super fast. I could go on this topic forever. We don't have time, but if you do want to dive deeper into this, there's a talk by Yahav Biran that's coming up. It's on build and deploy games faster with CI/CD pipelines. Check that out. It's really, really super important from a LiveOps perspective, and just from it makes your life as a developer, it's one less thing you have to worry about. It's super, super cool for everybody. So that's my thing on CI/CD, code pipeline, and fast deployment.
Thanks, Chris. And you touched on, a little bit of as you were developing quickly, you want to be able to push out all of those updates. So if you have, downloadable content that you created, any patches or any updates, you want to be able to get those first to the players playing your game in a efficient manner. So for what follows fast development are fast updates. And in order to get that content out to your players, it would be a content delivery network would be how you would do that. Now, AWS has Amazon CloudFront, which is a global network. It not just distributes the content with low latency, but it has high transfer speeds, and it has these things called edge locations, which are specific to CloudFront, and they are all around the world, and they are designed specifically to be where your players are playing for that low latency and for that ultimate experience.
Tabitha, let's go through a quick video of pinpoint journeys. So Tabitha mentioned pinpoint as a great way to keep your players engaged with campaigns and SMS and being able to segment your players. What we're going to do right now is we're going to go through an example of how we can use that using a new feature called pinpoint journeys. Journeys are neat. It's almost like a way to tell your players a new story that isn't part of your game. Right? It's a way to engage your players when they're not playing your game. And that's just as important as when they're playing your game, because it helps them think about it, your game, and get engaged and really want to start getting involved, right? What we're looking at here is we're looking at the beginning of creating your first journey for your players. Now, what we're looking at here is a segmentation of players. And what's neat about this is that these segments can be created by your servers programmatically as they're playing the game. Remember, we were talking about creating these profiles and understanding how they play the game. Well, what we've done is okay, some of these people are tanks and some of these people are active players or not active players. What we're going to do is be able to pick those players as we build out this journey. So what we're going to do is we're going to say only this group of players are going to take part in this journey, which is basically a series of emails that can tell them a story or do things for them in game. So in this case, what we're going to do is we're going to create a journey specifically just for the active players. And what we're going to do is we're going to give them some new content that's going into the game early. Okay. So what we do is we decide who's going to get this. And then what we do is start to add activities to this. It's kind of like an email workflow. It's a way to send the stuff out on a schedule. Like what we're looking at right here is we're sending this email out at a specific date. So we're going to start this campaign at a specific date and time. In this case, we're going to start it off in the past during GDC, or the week after GDC actually. And we're going to wait for that to happen, so that way our players have come out of GDC, we've got our new technology, and we want to wait until our launch date, which is right at this point. And now once we've waited until then, we're now going to start a new activity, and that activity is to send the email. And the email is the first part of the story, okay? And so we can tell our story, we can format our email however we normally would. Again, it's going to just my active players, and it's going to wait until that specific day. And then what we do is we choose the email template and we tell the story. We send the email, and they get it in their inbox, and they can choose to open it, not open it, interact with it, click a button on it, whatever. And what's of course cool about this stuff is that all of this stuff can then generate changes in your game as well, because Pinpoint can then record what's happened and act programmatically on those things. If they never opened it up, you'll know. If they open it up but don't click the button that you wanted to click, you'll know. If they click the button, you'll know. And what you can do is you can change things. You can give them in-game rewards for things like that. Or you can then do another activity based on whether or not they clicked something or not. So once again, we're looking at these different possibilities. The yes/no split, did they click the button? If they click the button, we can give them something else as well. We can set them up to have another email later on, or we can set them up to do something interesting in game programmatically, give them a toy, give them a pet, give them something interesting to play with, reward them for interacting. Or we can even basically have them go off on a different branch. Like if I looked at the email, but I never clicked on the button, I can then send them another email, which sends them down to a different branch of the story. If they did click on the button, we can go down this other branch here. So it gives us a way to start to tell interesting stories and engage our players in their game world without them even having to be playing the game. It gets them thinking about your game when they're not playing it. So they're more eager to get into the game. You know, if they're coming home from work, if they're on the bus, if they're, you know, playing on their phone and they're saying, oh, wow, I got an email, what's going on? And they can see, and they're like, oh, if I do this thing, I get a toy. So that's what the journey is about. And that's why it's called the journey, because it's about taking the segment of players that you've identified and giving them something fun to help them with their engagement in the game. So we're not going to show you the rest of this video. This basically shows all the specifics of how Journey works. Again, if they do a yes, if they do a no, you can see this is branching. While I'm talking here, you can do different activities based on how players behave. So that's why Journey is neat. It gives you another way to interact with them even when they're not playing your game.
Just like Amazon, very typical of Amazon to not just start, but also to end their presentation with a customer flywheel. We understand that your world completely revolves around, you know, not just your players, but the experiences that you give your players with your game. And hopefully you learned a few things about creating, not just unique experiences for the player community, but also with your team and in making your game. And thank you everyone for joining. We hope you learned about engaging, retaining, and delighting players with LiveOps on AWS. We have our emails on the screen, so please, feel free to use those and email us if you have any additional questions. Don't forget to explore any of the other sessions that we have. They will be on demand. And if you have any additional tech questions, you can stop by the Ask the Expert section to speak with additional AWS tech resources. And then any more details on LiveOps on AWS, check out the Resource Center. During the presentation, we talked about a couple links that we would resource, but you can get those here. And then we'll also put any other information that we think is relevant to using LiveOps on AWS. So again, thank you, everyone. Thanks for joining.
Thanks.